Hello everyone. As I discussed in last lecture, uh, today's I am going to discuss the various components used in the hydraulic systems and the pneumatic systems. So these hydraulic and pneumatic systems are actually comes under the actuators part of mechatronics. And first, uh, we will see the working and the function of your hydraulic and pneumatic system, and then uh, we will see some applications, best applications for hydraulic and pneumatic systems. Because for using the hydraulic and mechatronic systems as a actuator part of the mechatronic systems, there is need to understand uh, the mechatronics real mechatronics example based on the hydraulic and the pneumatic systems. Remember one thing, you are well familiar with the valves. So we are using different and various types of valves in these actuators, because these actuators are completely based on the mechanical functioning. So manually you can work with the hydraulic system and pneumatic system, there is no problem. There is a one manual switch or buttons by pressing which you can operate the hydraulic cylinder or pneumatic cylinders, and actually the working of these switches are changing the control position of the valves. But since it is a mechatronics, means uh, you have to incorporate your hydraulic and uh, pneumatic systems with the some controllers, because uh, the simple block diagram of mechatronic systems is uh, your sensors, then controller, and then actuators. So uh, after controller, uh, the signals coming from the controller is in the voltage or current form, you can say voltage. There is electrical signals. So by that electrical signals we have to work on the pneumatic and hydraulic systems. And since in hydraulic systems there is need of one reservoir as well as the uh, compressed fluid. So it is not very simple. It is a actually it is construction is simple, but for project based. So let us start with the first hydraulic systems. And uh, the basic principle of hydraulic systems comes from the very old theory that is called the Pascal's law. And earlier it is defined as a power generation by moving fluids. So uh, so by the moving fluids we can generate the power, we can transmit the power from one device to other device. But the recent definition of hydraulic system is not only the moving fluid, but it is a confined fluids. That is a we will make the fluids uh, with some pressure. That is the confined fluids. We apply some pressure, means the moving of fluids is not in a simple way but with the pressurized fluids. So I am going to present one PDF in front of you, in which we will see the definition of your hydraulic, and then uh, Actually, do not worry about the notes. These all videos I am going to be uploaded on your YouTube channel, so you can easily understand from the videos. Now let us concentrate on the hydraulic and pneumatic systems. So in this we will see the different components of hydraulic systems, and then working and functioning with a proper block diagram for the hydraulic system. Then we will go and we will see the live applications of the pneumatic systems, because in your stage, means at BTech level, uh, many projects are available uh, in mechatronics based on the pneumatic actuators. Means if in final year or in third year, uh, it is expected from you that you can design a simple and some innovative project of mechatronics, in which you can use the uh, pneumatic actuators. Hydraulic actuators is not possible at the project level, but frequently students are using the pneumatic actuators in mechanical engineering department. So I will show some examples of that projects. Now let us see the uh, hydraulic systems. Now see principles of hydraulics. Uh, as I told earlier, the word hydraulics generally refers to power produced by moving liquids, and it can transmit the power and multiply the forces. The meaning of multiply forces means you can convert uh, one Pascal pressures or one uh, uh, your Newton forces into a 10 to the 100, depending on the cross sectional area of the your inlet and outlet devices. So but and the simple Pascal theorem says here, pressure applied on a confined fluid. So this is the uh, actual key part of the your uh, hydraulic systems. So pressure applied on a confined fluid is transmitted in all directions with equal forces on equal areas. So when you change the area, that is the cross sectional area, the force is going to be multiplied. Now here is the one example of multiplying the forces. So you can see here the cross sectional area is going to be changed, and the fluid is confined within the two container of different sizes. So by applying a very small 1 pound input forces, and the cross sectional area is 1 inch square, it is going to be converted into the 100 pounds, because cross sectional area is going to be increased. It is a simple theory for the mechanical students. Now see, this is the block diagram of the hydraulic systems. Actually it is a generalized, but we will see the generalized with the uh, for hydraulic systems. So actually it starts with the hydraulic, you can say it starts with the reservoir, because to uh, to collect the pressurized fluids, there is a need to store the fluid. There is a need a tank, that is called the reservoir. And from the reservoir there is a two connections. The connection is called as a, one is called the pressure line which comes from the hydraulic pump. Here there is a hydraulic pump, and hydraulic pump is going to be operated by some mechanical mechanism or electrical mechanism, because this power supply is nothing but a motor. The motor may be operated by the, it may be a electrical motor, it may be a engine type of system, it may be a diesel motor, it may be any engine. So the power supply is not like a voltage supply and current supply. There is a one motor at the place of power supply, which is directly connected to the hydraulic pump. So in hydraulic pump, you know very well that different types of pumps available, and the work of pump to convert a simple. हेलो। अरे आपके जोशी सर वो लेक्चर ले रहे थे ना, इसलिए कॉल किया था। हाँ। So there is a one reservoir and one motor and hydraulic pump type of systems here. The key components of this hydraulic system is called the valve. This is your valve, and valve is not like this simple types of valve, because this valve is manual operated type of valves, but a number of valves we can use, and actually at this place we use the directional valve, because uh, we have a different valves available in mechanical engineering. One is called the DCV, that is the directional valves. One is called the pressure release valves. So pressure release valves is also important, and some other types of valves are also available. We will see in the valves part, but here there is a directional valves. uh, Now, after directional valves, to generate the actual motion, there is a one cylinder and piston types of arrangements are there. So the line which is coming from the hydraulic pump to the cylinder is called the pressure line, and it is always denoted by the P. It is called the pressure line. And when the fluid releases from the cylinder, it again come back to the your reservoir, and this type of arrangement is called the it is denoted by the T means this is a tank line, or sometimes it is denoted by the R, that is the return line. So you can say that this P is pressure line or pump line, P for pressure and P for pump, and the returning line is denoted by R or T for the tank line and R for the return line. So it is the low pressure, it always operates at the low pressure, and this operates at the very higher pressures. See, the connection of these valves and the cylinder piston type of devices are connected with a one your you can say one pipe, that is pressure pipe, and the return pipe, but it is not actually it is a there are two connections in the pistons. There are 2 points, one point at the upper side, which we can connect the pressure, and at the lower side there is a return of your uh, fluid to the reservoir. Since uh, your this fluid is very confined, and it is an incompressible type of fluid, as well as the purity of fluid is very high, so generally there is no need of any type of filters in the hydraulic system. However, if you go for the pneumatic systems, at the inlet of this pneumatic systems there is a requirement of air filter. Then there is a requirement of air treatment unit. In air treatment unit you have to mix your air with some lubricants to make it less corrosion devices, otherwise air will corrode the pneumatic systems and it will decrease the life cycle. But your hydraulic systems is the medium of hydraulic system is a good uh, incompressible fluid, so these type of problems can be avoided in the hydraulic systems. Now see one by one component, that is fluid, oil for hydraulic systems, air for pneumatics, reservoir that is called the storage tank, hydraulic pump, converts the mechanical energy into hydraulic energy. Means it makes the means your mechanical energy, that is the energy coming from the motor, is uh, uh, going to be imparted with the fluid and make it high pressurized fluid, that is also called the hydraulic energy. Hydraulic energy means fluid with pressures. So into hydraulic energy by forcing fluid from the reservoir into the system. Fluid lines, that is the transport the fluid to end from the pump through the hydraulic system. Then there is a valves. Valves may be control pressure, direction and flow rate of the hydraulic fluid. So there is a one valves. The important valves is DCB, directional control valves. Then the relief valves. The example of relief valves is a simple example. If you say there is a pressure cooker, so at the top of pressure cooker there is a relief valves available. So when pressure increases, it will relieve the systems. And one is your flow rate control valves. It will control the flow of your liquids, and it is the good example of controlling the flow is your simple tap. So as you move your tap in clockwise, uh, it will make the flow rate very less, and you can control the flow rate by manually or automatically by the help of some controller. Remember that controlling of hydraulic or pneumatic systems is not like your 5-volt game. It works on 220 volt, 200 volt, 140 volt, because for hello, is it audible?
Yes, sir.
Okay. So this is your key components for the hydraulic systems. Now see one by one. The fluid, it is oil for hydraulic systems. Reservoir, that is a storage tank. Hydraulic pumps, so it converts the mechanical energy, means it converts the energy of your motor into the fluids. Means hydraulic energy you can understand as a fluid with pressure, that is pressurized fluids called as a hydraulic energy. And then there is a fluid lines. There are two lines, one is the pressure line and the other is the return lines. Valves, we have to use the directional control valves as well as the flow rate valve. And then there is a one relief valves, and then it works as the actuators. Now these are the some examples of hydraulic systems, and uh, the good example is your excavators and the this heavy type of devices. uh, you can see at the top there is a one KUKA robot is here. It also works on the hydraulic systems. Now see the lifting of load mechanism. So uh, the lifting of load mechanism means there is a one reservoir, and in reservoir there is a establishment of pumps. So pumps are getting energized, means the rotating of these gears are from some motors, which you can consider the backside of this reservoir. So by these gear type of pumps, it will take the fluid from the reservoir, and the red line is called as a pressure line. So so it will red means there is a high pressure and blue means there is a less pressure. So the pressurized red line is going to be directional valve. Now directional valve has a four ports, two inlet ports and two outlet ports. Not you can say inlet outlet. It depends on the functioning. So you have a four ports. The P ports is called as the your the pressure port, or you can say P for the pump ports. So in some textbook you will find the pump ports and the tank ports. T for the tank ports is connected to the tank, and P is connected to the pump. In some textbook you will find that P is the pressure port and T is the termination port. In some textbooks, at the place of T you can find R, that is the return lines. So here you can understand the pump ports and the tank ports, and A and B is the user ports. Now see the functioning. Depending on this control valve's position, if it is at the lower position, at that time P is connected to the B, and when it is the no, when it is the upper connection, P is connected to the B, and when it is the lower condition, A is connected to the T. So at this time, P is connected to the B, but A is not connected to the T. Means your this cylinder pressure system is directly connected to the pressure pump. Here you can see that there is a pressure relief valve. So pressure relief valve has an arrangement of spring type of system and a sphere ball type of system. So spring maintain the blocking of this pressure line by this metal spheres, but as pressure increases beyond the prescribed value, this bulb is going to be downward pressed, and then there is a some pressure is or some pressurized fluids is going to be returned in the tank, and hence in pressure line there is a relief of pressure takes place. So this is the functioning of pressure relief valve. In directional control valve, in this position P is connected to B, and hence the lower side of piston has a higher pressure compared to the upper side, and hence it will move upward. But this is the simple functioning where you manually operate the DCV, directional control valve. But for mechatronic system, there is a requirement to energize a coil that is called the solenoid device. I think you have heard the name of solenoid. Solenoid is actually a coil type of mechanism. So when you energize the coil, the core of solenoid is going to be outward, and when you de-energize the coil, it is going to be inward. So by outward and inward means solenoid provides you can say linear motions. So by that linear motion you can press this. If you connect the solenoid at this position, so by applying 220 volt or by not applying voltages, you can energize and de-energize the coil, and hence you can press the button of directional control valve. So ultimately you have to connect these directional control valves to the controller part, so you can apply solenoid device here. So this is the lifting of your load. So your pressure at the lower side of piston is going to be increased compared to the upper side. So your this piston movement is in the upward direction, load is going to be upward. Now when you press the this you can say control of directional control valve, this is the control levers. So control levers can be pressed, and at that time A is now connected to the T, and there is no connection with the P and B, like that. So P is now connected with the A and T is connected to the B. In first, P is connected to the B and T is connected to A. So A, when connected to the T, there is a low pressure, and P connected to the B, there is a higher pressure. So movement is upward. Now the reverse condition is that P is connected to A and T is connected to the B. P is connected to A and T is connected to the B. Means in the upper side there is a higher pressure, and in the lower side there is a lesser pressure, and hence the movement of piston is in the downward side. So in examination you need to draw these two diagrams uh, for making your examiner for understanding of your examiner about the two different cases for the hydraulic system. So if you are able to draw and you have to draw the simple diagram, not like that. That is one rectangular box, and you can simply write down P, T, A, B, and you can make these two lines pipe. You can make cylinder piston type of devices. So in the simple way, you can make the block diagram of this hydraulic system, and uh, you have to explain the two different conditions for the hydraulic system, and then there is a requirement uh, to write some small notes for the various components, that what do you mean by the reservoir, pump, which types of sources required to operate the pump, operation of pressure relief valve, operation of directional control valve, and the pressure line and the your tank lines. Describe the pressure line and the tank line. So these two diagrams are sufficient to make your examiner understand about the hydraulic systems. So these are the various control valves: pressure control valves, flow control valves, and the directional control valves. So in we are using the pressure control, directional control valves, and the relief valves in previous diagram. And a number of discussion and different types of uh, pneumatic valves are available, but now there is no need to discuss the pneumatic from here. So you have to just discuss the these block diagram, simple block diagram of the hydraulic systems, and then components of the hydraulic systems, and then by these two diagrams the functioning example of your hydraulic systems. So it is all about the hydraulic system. Now, what is the advantage of the hydraulic system in comparison to the pneumatic system? Uh, it can lift the higher weight, and means it can operate for the higher torque system or higher force systems compared to the pneumatic. But mobility of your incompressible fluid is very less, so it is a the speed of operation is less uh, for hydraulic system. uh, since fluid is not noisy, so there's very less noise for the hydraulic systems. However, in the pneumatic system, it is a very noisy system, very fast systems, and uh, it, it work on a for low type of force and torque applications. And as well as for pneumatic, we require different types of treatment unit to make your air contamination free, as well as the mix some lubricants with your air to increase the life cycle of the pneumatic systems. So before sharing the some uh, key components of pneumatic systems, I wish to show some BTech projects based on the pneumatic systems.
हमारे वीडियो का टॉपिक है न्यूमेटिक सोलेनॉइड वाल्व क्या होता है, यह किस तरह काम करता है, हम इस वाल्व का यूज करके किसी भी सिलेंडर को ऑपरेट किस तरह किया जाता है। जैसे हेलो फ्रेंड्स आज का हमारे वीडियो का टॉपिक है न्यूमेटिक सोलेनॉइड वाल्व क्या होता है।
This video will describe how industrial pneumatic systems work. These 5 types of components represent the most common elements used in these systems. The ultimate goal of this entire collection of components, in most cases, is to create motion that will do some type of work in an industrial setting. Pneumatics is one of the most widely used technologies to automate repetitive processes. Some common applications might be to move product from one place to another, or to press or clamp pieces of a product together. To best understand how the system works, we will start at the beginning with the compressor and follow the process through to the end goal of motion. The compressor generates the energy that powers the system in the form of compressed air. In order to generate compressed air, the compressor draws in atmosphere from its surroundings and squeezes it or confines it into a smaller space, creating the energy needed to drive the system. Once compressed, the air needs to be dried and cleaned so that harmful particulates such as rust or dirt does not clog up the moving parts in the system. The compressed air will travel through a tube or line to the next component, called an air preparation unit, or FRL. FRL is short for filter, regulator, and lubricator, which are common pieces that make up the air preparation unit. Typically, the first unit in the air preparation system is what is called a bulk liquid separator, which circulates or spins the air using specially shaped vanes. The rapid circulation of the pressurized air sheds unwanted moisture due to centrifugal force. The next unit is a filter, which further removes particulate and moisture in a two-stage process. Just like in the bulk liquid separator, a series of vanes or louvers in the filter circulates the air in the first stage. In the second stage, the air passes through a screen of sorts, called an element, in order to catch unwanted debris. Once dried and cleaned, it is common to adjust the level of air pressure coming out of the compressor. This adjustment has an impact on how much force the system generates. Higher pressure allows the actuator to put out more force, and lower pressure creates less force. The regulator achieves this using a spring-loaded assembly. The knob on the regulator adjusts the force of the control spring to achieve a desired pressure set point. Whenever the downstream pressure level drops lower than the desired set point, the poppet, or internal valve, opens a pathway for the higher pressure upstream to flow downstream. This continues until the pressure in the system reaches the regulator's set pressure. At this point, the poppet or internal valve closes until there is a new downstream demand. It is also common to have a pressure gauge on a regulator so the user can monitor downstream pressure. Finally, in specific applications, such as air motors or pneumatic tools, a lubricator can be added to distribute a fine mist of lubricant into the compressed air to help lubricate downstream components. Now that the compressed air is clean, dry, and set to the correct pressure for the application, the next step is to direct it where to go to create motion. A directional control valve is used to achieve this task. This directional control valve has a series of internal pathways that can connect the air coming into the inlet port with one of 2 avenues to leave the valve, called working ports. Depending on the position of the moving element, which is typically called a spool, the air will be blocked from traveling down one pathway and allowed to travel down the other. The high spots on the spool, called lands, will block the air from proceeding down one path, while the lower sections on the spool, called grooves, will allow air to flow around them and proceed to one of the working ports. In this common type of valve, when the unit is not activated, the spool is forced to the left side of the valve by a spring. In this position, you can see that this land blocks air from going out the number 4 working port, and instead is forced to go out working port number 2, because the grooved lower section of the spool allows air to flow past it and out to the number 2 working port. In order to change the direction of the air to the number 4 working port, the valve needs to be turned on. In most automated equipment, a PLC, or programmable logic controller will instruct the valve to shift using an electrical signal. When the signal arrives at a portion of the valve called a solenoid coil, a magnetic field is created that pulls a cylindrical piece called a plunger towards it. When that plunger is unseated, it allows air from inside the valve, known as pilot pressure, to push the spool to the right. Once the spool reaches the far right side of the valve, the lands or high spots are now closing off the passage to the number 2 working port, and instead directing the compressed air to flow to the number 4 working port. When the signal from the PLC is removed, the force generated by the electromagnet is also removed, at which point the spring on the plunger returns it to its normal state, which removes the air signal that is pushing on the spool. The spring on the opposite end will return the spool to its default position once again, directing air back out the number 2 working port. The PLC can now direct air to whichever port is needed whenever it is needed. The next component in the system, the actuator, will allow us to do some useful work with the air we compressed, cleaned, and redirected. In most applications, the purpose of changing the direction of the compressed air with the valve is to cause motion in different directions. Parker makes a wide variety of actuators, or cylinders as they are also commonly called, that will convert compressed air into motion. The most common type of cylinder is the rodded variety displayed here. The actuator will create motion using the energy of the compressed air that is supplied to it by the directional control valve. We can see that the working port number 4 is connected to the back or cap end of the cylinder. When the compressed air pushes on the piston, it is forced to move forward inside a hollow cylinder that is commonly called the body. The piston is attached to a rod that will extend as a result of the force generated by the compressed air acting on the piston. The actuator will continue to move in that direction until it reaches its physical limit, or if the force resisting motion, commonly called the load, is higher than the force of the compressed air, in which case the pressure regulator could be adjusted to a higher pressure. Now that we have completed the extension, we will need a method to retract the actuator to its original position. The directional control valve will achieve this by changing the direction the compressed air flows from number 4 working port to the number 2 working port. The number 2 working port is connecting to the head end of the actuator, and when the compressed air pushes on the opposite side of the piston, it will reverse the direction of the piston rod assembly. This reverse motion is typically referred to as retracting. For this actuator to retract, the air that is already filling the cylinder needs to go somewhere, which is commonly referred to as exhausting. The exhaust air is illustrated by the red color and is shown exiting the cylinder and flowing back through the valve, out the muffler to the atmosphere. This system can repeat this process as often as the PLC tells it to move things from point A to point B in one example. In this example, the PLC is telling the actuator to move this product by sending a signal to the directional control valve, which is using the clean, dry, compressed energy to power the actuator. Pneumatics are also commonly used to press 2 components together in an assembly process to help form a finished good. Through the combination of Parker's air preparation, valve, and actuator products, there's a wide range of applications that can be solved. Visit us at parker.com to explore all of the pneumatic products we have to offer.
Hey everyone, if you're trying to learn Python, Udemy has a huge selection of online